Hello, so today we are going to try to solve this problem called longest arithmetic sequence. So the problem says we have an array and we want to return the length of the longest arithmetic subsequence. And subsequence is arithmetic if the difference between the element and the next is all the same. So 3, 6, the difference 3, 6, 7, the difference 3, 9, 12, the difference is 3 as well. So the length here is the entire array, so it's 4. For this one, seems like, let's see, difference between 4 and 7 is 3, but that's set, so we can't rely on that. 4, 7, 10, so it's subsequence, it doesn't have to be contiguous. So between 4 and 7, that's 3. Between 7 and 10, that's 3. So the entire subsequence is 4, 7, 10. Okay, let's see how we can solve this. So so the problem is subsequence, right? So non-contiguous. And the main idea is that bi plus 1 minus bi is the same. So for each element we need only we need the last element in the sequence, right? And then the goal here is to return the length of longest one, right? So what would be the state here? We definitely need the position we are at each moment. We need last element, last in sequence, and then we need the length of the sequence as well. And we also need not just the last in the sequence, we need the difference, right? The difference we are working with. So that would mean maybe we could have helper, last, or maybe call it latest, last, yeah, diff, and length. And so what this would mean is that for each element, the choices are, so basically the choices are use or skip, right? And here condition is that AI minus last is equal to diff, right? And then we could increase the length. So what would be the helper function for the use case? The helper call would be, well, it would be if we have this, then we can do helper for I plus 1 and the last. So last is going to change, right? Diff is still the same. And we may need another choice, like start looking for a new arithmetic sequence, right? One between the two adjacent elements. And then this would be L plus 1. The other option is just continue looking, so that would be I plus 1, last, diff, L. The other option is to say if, well, or no need for if, but I plus 1, and the last would be AI. Diff would be AI minus 1. Minus AI. or actually the reverse. This can happen only if I is bigger than 0. And then the length is just 1, right? The length here is 2 actually. I think this covers it, so let's try it. Now if n is equal to I is equal to n, we'll define n later, then we want to return so if I is equal to n, we will need to define n here, think of a, then we want to return L, right? And then here we want to initialize the call, so that would be to, we want to return it, that would be to 0, last, just put none, right? And then diff none, and then L is L is 0, right? So here what we do is we okay, so now here the next step is the use case, so the use choice, so that will be like this. The other step is the skip, and then starting a new arithmetic sequence. So this is use, this is skip. Okay, let's just put it like that. Let's run this. We can memorize it if this works. Okay, so here we can do that only if last. And there's a problem here as well, so the problem if I do this is that the first call won't launch at all. So maybe here I could do 1. I could try 1 and 0, right? So I could just do max. Here it would be 0, and there it would be 1. The last here is a 0. Diff is 0. The length is 1. And 1 here. Last is 1. Diff is 0. Length is 1. Here as well we should take the max, so between all of this, so choice 1. So 2. C3. and at the end return max of C1, C2, C3. Okay. Problem is with the last element there. This one. 20, 15, 10. Well, actually, it should be 4. My function returns 2. So let's see what's up with this one. Technically, we don't need this 8 because it stops at 5. Let's try to remove maybe 3. Okay. If I remove 5, 15 there. Okay, so what if it's just 15, 10, and 5? That works. So it's not the problem there is not the descending nature of it. Okay, so here if the difference is equal to diff, we should do L plus 1. Zero, 1, 2, 3, 4, 5. So when it reaches 5, last was 5. Shouldn't I here be 6 actually? So the difference is 5, right, between them. So strange that I equal to 6 never appeared. Let me catch it so we can have fewer calls here. And so from functions import LRU cache. Okay. So we still tried 0. So here actually I should be 1, and we should the difference we have here should be, I don't know actually, so the diff is -5, that's the correct one here. The problem is that we reach length equal to 3 and end there, but we should have, why is length equal to 3 instead of, so when the last was I don't think with E19 I don't need this. Let's see. Oh, probably do actually. The one that we may not need is this one. Actually, let's try to make this shorter. This input shorter. So seems like it fails whenever I introduce one in the middle. If I introduce that one here, it works fine. So it seems like potentially it's this the problem is here. Yeah, only on the first one. So I think we don't need to do this because skip will handle that anyway, right? So would skip handle this, so we don't need this anymore. So this would mean the diff here is 0 and the element is 1. Okay, I think we need, let me try to debug this with the debugger. Okay, cool. Take this, fine, call a function on it, and pass the array here, and then let's print our solution. Actually, what we want is the array cosinus problems, so that will be this one. Let's try to debug it. Yeah, first let me fix that, and let's try to try to debug what's happening. Okay, so diff is 0, last is 20. Yep, cool. So AI is 20, last is 0, 20 minus diff is 0, so that's not the case, is it? Because, yep, last is the same element, 20. Yep, so that's definitely a problem with this one already. So this needs to be 1 for the next element, and then we don't need this one. But we definitely need one where we skip it. So here the last one need to be 2. The element is A1. The diff is 0. Okay. I guess one of the problems I'm encountering here is how do I account for okay, let's just start from 0, give this as none, diff as none, and the length as 0, right? So what this would mean is that here if last, and for C2 for skipping, that's fine. This one, so that would be A0. What if we try, let's try to write down the problem we have here. So the main issue is that is how to handle the first element so that we can start the proof. And the main problem here is the state I have where we have diff there. So what if I just pass something different like last and before last, right? That would definitely solve the problem, right? So I would say last here, before last. That way I can say this is just last minus before last. And I could send none for this one as well. I could send none here, and then the length is still 0. We just need 2 nuns here. So this is before last, and this is last. Now with this, the AI is still the same. Before last is last. When we skip, we still have the same values. So last, before last here. If we are doing a new one, then this would be before last. If I bigger than 0, else we need to just say none. And we could say that the length is going to be 1. So here and before last. Why is it? Okay, let's try with a simpler example. This one, 369. Okay. Okay, so there is a problem there, definitely. So let's try to see why. Okay, so we call again with I plus 1. Okay, it seems like there is it's off by 1. So here actually, if so 1, if I bigger than 0, then it's 2, else should be 1. So that's correct there. It's not correct for this one, which should have said 3. Does it say? Should have said 3 here, because 20, 15, and 10. Does it say 3 for this one? No, it doesn't. Okay, I think there is no use in debugging this. It's pretty complex and it doesn't seem good enough. So either I can directly use a DP, an iterative DP, and use a hash map to know how many same differences I have encountered before. So if I do that, maybe I can do that with this one actually. Okay, actually, let me just try with DP here. So if I do this, then diff is going to be the length of longest arithmetic sequence ending at I with difference with diff, right? Difference diff. And then I will need diff map, right? And so let's try this here. So diff map is going to be collections. It's going to be something like that. And then we'll just need to iterate through. We just need the length of the array here and iterate through for n, for g, range of I plus 1 n, dp of g. Actually, I need diff, right? So here I need diff, or maybe I could just do all the ones after it. This is going to be ag minus ai, and then dp of g is going to be all the occurrences that have the same difference. So that will be diff map get or default. So get or default map Python. Yep, I could just use get here. So get for d, default is 2. So here this will need to be d. And at the end here, we're going to return max of dp of I. So for any difference in any length ending at any I, we want to take the max dp of, we want to take the max of this. So we need dp here, which is going to be, we need the max diff possible. So max diff is going to be max of a minus min of a. That way we know that our dp needs to be 0. In range of so these are the, for each row, these are the values, right? And then the rows are for in range of n plus 1. How are we going to use dp of I, right? So definitely need dp of I d. I think having these two is complicating things a little bit more. So let's try with just making this a map itself. And what this would mean here is that dp of I and d, this is j actually, so this would be between I and d. These are the and then that would be dp of I d, right? Let's get that, and then default to 1 if it doesn't exist, because then we have just ai, and then do +1, and then here we can just take the values. Okay. Okay, cool. Okay, so that passes. Cool.